Wilson, nice to see you again. Gina, old friend. Have you done this exact worksheet?
Probably. We did one of them a couple days ago that we did.
Really? The exact same one? Well, it's a good thing I'm using this as notes and not as the actual assignment. That's a good thing.
Still have it. Yeah, no, I threw all that away.
Burned it, had a good old-fashioned bonfire.
I know what it is. It's a lie.
So, we are not going to take a field trip to see Gina Wilson. Now, so if you've done this exact worksheet before, then you know how to do this. So, to solve a quadratic by factoring, the very first thing you have to do is make it equal 0. So, you can see that some of these quadratics are like set up already. They have everything on one side, 0 on the other side, and then you can see if you flip the page over that some of these have terms on both sides, so they are not quite ready yet to be solved. So the very first thing you're going to do is move everything to one side to equal 0. The next step is factor, and so you just have to remember your different methods of factoring. You've got your GCF, you've got your regular trinomials, you've got your slide divide, because we are not using slip and slide as what we call things anymore, and then you've got your difference of squares. And then after that, you're going to take each of the factors and equal to 0 to solve. And then I'm not very nitpicky about writing your answer this way, but you can if you need to. All right? So you don't have to do the little squiggly brackets. You can just say x equals. That's fine. I don't really care.
She was no. If we could do the second picture, and so my squiggly wasn't defined enough, but it was there. Those are defined enough.
You have lots of trauma here.
She was like, I don't know if that's curved or squiggly, and she was like, and I was like, oh, I'm sorry, and it takes up like 5 points. And I was like. Okay. I
see. Well, on the activity for today, they do have the squiggly brackets, but if you don't put them on your assignments, I could not care less. So, all right, let's go ahead. I will not be sending this recording to your last year's teacher. That would be very offensive to her. It would hurt her feelings. No, goodness gracious. So much sass in this room right now. Let's go ahead and get started. I'm trying to redirect. Let's redirect. Okay, so if we look at number 1, what type of factoring problem is number 1? It already equals 0, so it's ready to go. So what type of factoring problem is number 1? Yeah, GCF. Square. Circle. Star.
Like, what is it called? Like,
Difference of squares? It's not difference of squares because it has a plus. Oh, okay. So it's GCF, and what is the GCF? X. Okay, so we're going to take an X out, and we still have 2 terms left over. X plus 9. All right, and then, so we did the first step was already done. The second step was to factor. We did that using GCF. The third step is to take each of the factors and set them equal to 0. So the first one is easy. You set it equal to 0, and you're done. The second one, x plus 9 equals 0. You have a little bit more work to do. How do you solve for x? Yes. Subtract the 9. X equals negative 9. And this is where we can ditch step 4. You can just put a box around those. Whew. Do you feel just so free? So free. Which part? You take each factor and you set them equal to 0. Yeah. All right, let's hop over to number 4. Whew. Did you like that hop? We were here, and then we went hop, number 4. That's pretty good. Wasn't it good? Okay. You guys can imagine how good my jokes were in a teaching setting where there were no responses. It was just silence. You can imagine. It was pretty. All right. So what type of factoring is this? Yeah, this is that difference of squares. So this is, what would be the square root of 9? 3. Okay, so this is 3x squared minus what squared? 5 squared. Okay, so that's the difference of squares. So then if we do our 2 sets of parentheses, what is going to go in each set? plus 5. Okay, we got to change the signs in there. All right, so it was equaling 0 when we got started. And then we recognized that when we factor this, it was difference of squares. And so we did that factoring method. And then what is our next step? Setting them equal to 0. So we're going to do 3x minus 5 equals 0. And 3x plus 5 equals 0. And what do we do to solve for x? For this one. Okay, so add 5. And that gives us 3x equals 5. Gross. And then divide by 3. So x equals 5/3. Ew, fractions! But no squiggly brackets, so we made a nice compromise. We got a fraction, but no squiggly brackets. And then what do we do for the other one? Well, not quite the same thing. Subtract the 5, okay. And then divide by 3. X equals negative 5/3. What a beautiful problem. I truly enjoyed that one. What a wonderful time was had. Okay. All right, let's do number 6. It equals 0. Did you see that hop? That was just, it was such a slight hop, you could barely see it. It truly showed my athleticism, but if you blinked, you missed it, you know? All right, it equals 0 already. So now we're on to the factoring part. And what type of factoring do we have? Yeah, GCF. Okay, I thought it was going to be tricky, but I wasn't. All right, so we got the 2. Oh, that's okay. Now, I will say, though, in that board game, a lot of you guys got tricked by the GCFs. A lot of you guys just, like, divided by those 2s, and then you dropped them. And then you were like, let me ditch that 2 real quick. Let me leave it out of there, but it's not left out. All right. Okay, and then what's left over? Marvelous. Okay. So we are finding 2 numbers that multiply to negative 12, but add to negative 1. Or positive 3. So I'm keeping my GCF of 2 in the front. X minus 4, x plus 3. Okay, this is the one thing I'm a stickler on that students get annoyed by, and I'll tell you in a second what it is. Okay, I'm going to take each of my factors, set them equal to 0. I'm going to play devil's advocate right here. I'm going to be like 2 equals 0. And you're going to be like, Ms. Wright, that is not true, right? And so I'm going to go, okay, that's not an answer then. See how easy that was? Okay, all right. I set it equal to 0, but it's not an answer. Okay, let's move on. So the 2 tells us nothing. The 2 doesn't give us an answer, but it's still important because it's part of the factoring. So we can't leave it out. We got to keep it because they said factor solve, so we can't just ditch it because it's part of it. Okay. I should make that something that would kill an animal, actually. I want you to leave the 2 in there. Yes. That is the thing that I nitpick, and students go, well, it doesn't matter because it's not part of the answer. And I go, well, it's part of factoring, and it said factor to solve. Does that make sense? It matters too. Sophie, what were you going to say? Thank you. If it was in the original problem, if the original problem had a GCF, your factors need to reflect that there was a GCF. Absolutely. Okay. And then we have x minus 4 equals 0. And then we have x plus 3 equals 0. Ooh, we are steps like rebels. Boom. Shakalaka. Like they said back in the days. Boom shakalaka. All right. Let's flip the page over. I feel like these are getting boring. All right. Let's try. Let's try 13. Yeah, let's try 13 first. Let's try 13 first. Okay. What needs to happen to number 13? Is it ready to go?
No.
It is not. We need to move the 80 over to the other side. 0. Minus 80 plus 2x. Is that how it should be written? No. Ugh. How should it be written? Ugh, Miss Rice, you silly goose. Silly goose. Okay. So we've done the first step. That was so much work. It finally equals 0, and it's in the right order. Now what should we do? Factor. So we're looking for two numbers that multiply to negative 80, but add to 2. $10 and 8. 10 and negative 8. I thought you were just showing me your fingers. Okay, so then we've got x plus 10 equals 0, x minus 8 equals 0, x equals negative 10, x equals 8. Does anyone feel a lot of satisfaction out of boxing these answers instead of... When I was a teenager, to always wash Ziploc bags. Like, she had a Ziploc bag drying rack and everything. Yes. Yes, all the Ziploc bags in my house were very, very old looking. And as an adult, I get a sick satisfaction out of throwing Ziploc bags away. I use them once, and I throw them away. They still look brand new. It's very bad for the environment, and I love it. I don't love that it's bad for the environment. I recycle everything else. That is recycling them. That's like, I don't think so, because I don't think so. Well, you can recycle some plastic, but I don't see, anyway, the best way to recycle them, I think, would be to reuse them and not buy as many, or to not use Ziploc bags at all and to use something else. But because of my childhood, Sophie, you'll probably end up doing this too. Because of my childhood and the deep emotional scars I have from that, I get a sick satisfaction out of putting a sandwich in a Ziploc bag, eating the sandwich, seeing one crumb, and going, oh, it's dirty, throw it away. It is. Yeah. Oh, see, those are bad for the little fishies. You got to use the metal straws, and then you got to throw. No, they don't. Use the metal straws that have the little like silicone on the end. And then at Smoothie King, you can say, no, I've got my own straw. Save the fishies. You know? Okay, we're getting off track. Anyway, I was saying that putting a box around this is kind of like throwing a Ziploc bag away. Feels very satisfying. All right, let's move on. Number 16. Number 16. I don't think Asa agreed with my comparison there. I felt like it was pretty solid. I felt like I was going somewhere with that comparison, and I felt like it was solid. All right. What do I need to do? Move them. Move them. All right, minus 2. Okay, and then add the 3x. And that is now 0. So we've got 4x squared plus 44x plus 96. Ooh. Is there a GCF? Okay, 4 x plus 11x plus 24. Cool. Yeah. Not slip and slide.
No.
Not slip and slide. Just factor. Not slide and slip.
Don't do any of that. It's like the thing where you just factor them.
Yeah, so multiplies to 24, adds to 11, 8 and 3. So keep the GCF in the front. So we keep the GCF in the front because all numbers have value. Get it? Get it? All numbers have. Instead of saying all people had value, I said all numbers have value because numbers are okay. I'm moving on.
Oh, because they have value.
Because they're number. Okay. Man, I am on it today. I am on it today. All right. So based on this, what are the answers? Does the 4 give us anything? Okay, so we're like, oh, this factor equals 0. Oh, no, it doesn't. That's silly. Okay. What is this answer? Oh, that's -8. You got that very fast. All right, x plus 3 equals 0. Oh. Okay, x equals -3. Okay. Box my answers because I'm feeling sassy, so I'm putting a box, not a squiggly bracket.
You should go have a meeting with Miss Judd.
It is not wrong to put a squiggly bracket. It is not. It is, in fact, more accurate to do so because then you're saying this. The squiggly bracket is it is formal. It's formal notation. It means the solution set. The solution set is these numbers. It is formal notation. I'm just telling you that we can be informal. That's all I'm telling you. All right. Let's try number 17. Let's try number 17. All right, now on problems like this, a lot of students would be like, oh, subtract the 2x squared over because it's, easier to subtract one thing. But it is easier you are doing factoring if the x squared term is positive. Because then you don't have to mess with the negative. So we're going to subtract x over, subtract the 21 over. So we got 0 on the right side. And then that leaves me with x squared minus 21, right? No.
X squared minus x minus.
Okay, so you're telling me that I can't subtract those. Why not? They're not like terms. Oh, okay. Just checking, making sure we're awake, making sure we're not killing any baby animals here. That was the biggest first world problem complaint I've heard in a long time. We are not awake. It is like 8:30 a.m. So, we're looking for something that multiplies to -21 and adds to -1? No. No. Okay. So, we're looking for something that multiplies to -42 and adds to -1. 21 and 6? 7 and 6. Okay, sorry, I just heard a random 21 out there. All right, so x minus 7, x plus 6, and we're done factoring, right? That's just it? You have to divide by 2. Okay. Sorry, this problem is just very difficult for me, so I'm just checking you guys, making sure you tell me my steps along the way. All right, so I've got 2x minus 7. I'm not even going to ask Alex how to do that because she's going to make an alcohol joke. And then for this one, what do I have? X plus 3, okay. So I've got 2x minus 7 equals 0. And then my answer is just x equals 7, right? And then over there, what's my answer?
X equals
7 halves, okay. And then over here, x plus 3 equals 0. And then what does x equal? Is it halves? Just 3. Okay. Because there was no 2 in front of the x, so we didn't have to divide by 2. Okay. How do you feel about using the method of factoring to solve problems? Can we do which one? Let's do 9. Yeah. We can do it real quick. It's a good one. It's a good one. All right, one last problem before we move on. Number 9, how do we do it? Okay. So 2x squared minus 5x equals 0. Okay, and when you divide by the x, does it just disappear? No, what do you do with it? It goes on the outside. Okay, and then what do you have on the inside? Okay. Equals 0. Okay. And then what do we do? X equals 0. And this one actually works, right? Because before we had numbers in the front and we'd be like, oh, 2 equals 0 and that didn't work, or 4 equals 0 and that didn't work. But this time we have an x in the front and x equals 0 legitimately works. So that is an actual answer. And then over here we have 2x minus 5 equals 0. And so, yep, so we're going to add the 5 over. And then we're going to divide the 2 over, and what do we get? 5 halves. Okay. All right. As you look at the sheet, are there any other problems where you're like, yeah, I could benefit from seeing that one? No? You feel like you got it? Okay. Move this off to the side. It just became homework. I know, I tricked you. It was so great. I feel really satisfied. It was the most evil thing I've ever done to this class, and I feel a little bit satisfied. Then I would just pull my camera up and I would record, and I'd be like, look at these first world children crying because I tricked them. All right, so we are going to play a game of Math Clue. It is, so that's what these are. These are the locations, the murder weapons, and the potential murderers. Was it the same one? Who killed Mr. Factor? Mr. Factor. Oh, it's not always the wife. In this case, it's not the, okay, if we look at the stats, no, listen carefully. If we look at the stats, we're going to pause for math, we're going to be serious for a moment. There are not as many female killers as males. So if this said who killed Mrs. Factor, 100% I would agree with you, it's probably Mr. Factor, okay? But when we talk about the reverse, not as likely to be Mrs. Factor, okay? For real, statistics tell us that women do not often do killings but if a woman did kill a man, it would definitely be poison. That's all I'm saying. Okay, so back to math. Yes, back to math, because they can't watch it happen. It can't be with their bare hands, things like that. They can't see it. So it has to be like something emotionally detached. Okay, so let's move on. Who killed Factor? Mrs. Factor is not even an option, so you guys are already wrong. F's to all of you who said Mrs. Factor. Sorry, Macy. You were the only one I remember saying Mrs. Factor. Macy and Jack. Already F's because you already... You both said Mrs. Factor, so you both get F's because you're both wrong already. All right, so let's go ahead and move on. So we have to solve killed Mr. Factor. What did they use, and where did it happen? Okay, so here's how the assignment works. You listen carefully. You solve the factoring problem, and then you look around the room for that answer. Okay. And if you can find the answer, it's going to correlate to one of these things. When you find that answer correlating to one of these things, you can cross it off the list. That is not it. Does that make sense? So factor the problems, look for the answers around the room. When you can find those answers, that means that is not the person, that is not the place, that is not the item used to kill Mr. Factor. Sure. By all means. All right. or hung him from a rafter. But hanging. Well, when you hang, a lot of times it breaks their neck. Okay. This is. I'm teaching you some about history and science here. Health class. True crime. True crime is better. All right. So let me go ahead and pass this out. So I clumped these together. They were such small little cards. I clumped them together in pairs, not because those pairs are true, but just because if I put one around the room, you'd have a hard time locating them. Okay. All right. Any questions about how the activity works? Got it?